I expect to grade the other half maybe tonight, maybe tomorrow. I want to hand them back on Wednesday. I will post the grades when I grade them. The grades for this homework are not posted to Blackboard because I wanted to do one giant chunk of posting to Blackboard. But yeah, the midterms look good. In general, it's if you wrote something, you got a good portion of the points. If you didn't put something for that answer, you didn't get points for that answer. But in general, the grades are looking very good. Actually, higher than usual for one of my exams. So either the take-home portion, the take-home idea of it was very beneficial, or I made it too easy. Either way, you got good grades. So.
Don't worry about it.
I don't know how the final's going to be.
Lesson encouragement.
Yes.
So I don't get it, you know? So I stayed up and didn't sleep all weekend. And can you take two indexes, which I know I can, fill them both, right? With whatever, and you can declare how many indexes. So I wrote this program that says, I'm trying to get the cost of menu items. So one plate of food, how many ingredients, 5, what's the cost of bulk, and the percentage used, and then add them all up.
Mm-hmm.
How do you go through the index? I can get the indexes to average as a whole, but I can't go to compare index 0 to index 0 to this index 0, then compare index 1 to this index 1. You know what I mean?
So
2 to 2, 3 to 3.
Let me make sure I'm understanding your question.
Have I gone over that? Do I need to know that?
You have 2 arrays.
Yeah, I have 2 arrays.
And you're trying to compare, say, element 5 in the first array to element 5 in the second array.
Let's see.
But
I want to do. Yeah, it's not like sorting. I read the thing on sorting, and it's almost like that. I could maybe do some element of sorting to do that. I don't know. But yeah, go through 0 through 5 and compare 0 to 0, 1 to 1, 2 to 3
So the starting point is you're looping through elements, iterating through elements. So you need some sort of loop. Since the index into both arrays is going to be the same, you can have a loop with one index, with one variable that represents the index you're looking at, and then do your comparison on array A index I versus array B adding index I. Does that kind of answer your question?
Do it. Maybe after I'll show you what I got.
Okay.
Because I tried to do a counter on it and count up the indexes and do all.
Okay.
Yeah. But it's and then that has nothing to do with multi-dimensional arrays, does it?
No, if both arrays are a single dimension, then it doesn't do
Make a
anything.
multi-dimensional array.
It really depends on what you're doing. But having a multi-dimensional array won't necessarily help the issue you're having.
Okay.
Might be easier to think about in terms of storage, but I don't think it'll improve the situation you're doing.
Okay. So it's just something.
And I'll look at it after.
Yeah, cool. Because appreciate it. Just the fact that because I can compare it to array if I want to compare individual elements of those without having to. Otherwise, the array's pointless. You have to type out which index every time.
Mm-hmm. Right. Okay, so today I'm talking about most of Chapter 8, sections 8.1 through 8.3. So any questions on the reading before we dive in? Cool. And for those of you who walked in late, see me after class for homeworks, old homeworks, recent homeworks. I have them all. I don't have exams yet. All right, so Chapter 8 is really the second half of object-oriented programming. The first half of object-oriented programming was very early on, or at least earlier. I don't even remember where. The encapsulation and information hiding portion. So it looks like Chapter 5. So Chapter 5 was the first half of object-oriented programming, and Chapter 8 is the second half of object-oriented programming. We already mentioned, and one of the midterm questions was, what is object-oriented programming? What does it mean? So to this point, we've dealt with object-oriented programming in terms of thinking of our programming world in terms of real-world objects, so that things are easier to manipulate, deal with, group into logical categories. And in this chapter, we're going to extend that metaphor. So the three, usually they're called the three pillars of object-oriented programming, are encapsulation, polymorphism, and inheritance. Encapsulation we've already seen. That means each thing is responsible for its own actions, operations, and it creates this kind of contract of trust. I am responsible for doing what I am responsible for doing. I assume that something else is responsible for whatever it's responsible for doing, and it does the right thing. So, for the homework that I just handed back, we built a car class, and the assumption is that car does everything that pertains to car. When we write our main method, and in the programming assignment that I think is due today, we assume that from the perspective of the fleet class, car does what it's supposed to do. We really don't care how car does it. We assume that car can drive. We assume that we can fill the tank of the car. We assume that we can change the oil in the car. We're not worried about those implementation details. So that's it. Encapsulation, also sometimes called information hiding. I like to emphasize the division of responsibilities aspect as well. Each class is responsible for a specific thing, responsible for doing it correctly and right, and that means that everything else doesn't have to worry about whatever those classes are responsible for doing. The other two concepts are polymorphism and inheritance. Polymorphism is something that we'll actually see in action, and it's a lot easier to explain when we see it in action. It's basically, it's a Greek word, or it comes from Greek. Its parts are poly and morph. It's something that can take many forms. The basic idea is that we can name a bunch of things the exact same name, and depending on context and some other situations in Java, the runtime will pick the right one. We've already seen this in terms of the toString method. If we don't specify a toString method on a class, Java uses a default one. And later on in this chapter, we actually find out why that is. Whereas if we specify our own toString method, that's the one that Java picks. And Java doesn't link those up at compile time. It's at runtime when the toString method is actually called, Java figures out what method is actually supposed to run. This is sometimes called dynamic binding. Dynamic binding really refers to something slightly different. It's really called late binding. Basically, it means it's kind of a just-in-time idea. As soon as I call toString, Java just-in-time fits the toString method in that gets executed. So that's polymorphism. The last one is inheritance. And this is really probably the most obvious thing that completes the whole object-oriented idea. We've already represented real-world things in terms of classes and objects. But in the real world, things have certain hierarchies. The usual example is a dog is an animal. A cat is an animal. A plant is not an animal. that sort of thing. We can build these hierarchies, and in that case, it's basically a taxonomy. Everything starts out fitting into one category, which in the real world, that's kind of a thing. Everything has some thingness to it. And in the real world, that has some specific definition. In Java, there's also something like that, but in Java, instead of calling it thing, they call it object. So in Java, everything is an object, which gives it certain capabilities. Because it's an object, Java can treat it as an object. It has a reference, which we've seen with the default toString method. It has some name and it has some specification. It also has a lot more things that are, you can look at the documentation of object and see what exactly it can do. But we're not really concerned about all of those nitty-gritty details. But from object, then we have things that basically inherit things from that. And that's the word that Java uses and the word that object-oriented programming uses. This idea of inheritance. It's not passing money from one generation to the other. It's passing, I shouldn't use the term passing, but it's providing things like methods, member variables, basically the same thing that objects have. Attributes and operations from things at the top of the inheritance hierarchy to things at the bottom of the inheritance hierarchy. So since everything automatically in Java is an object, it has things like toString, a reference, a name. And if we were to create a class called animal, for instance, and give it certain abilities like move, eat, speak, some generic things that embody animalness, we could then say a dog is an animal and give it specific, more specific behaviors. A dog can wag its tail, for instance. A dog can act really happy. A dog can act mopey. In general, animals, while animals still have emotions, it's very hard to tell whether they have emotions. A snake, it's very difficult to tell if it's happy or sad. Easy to tell if it's hungry, though. So as we go down the inheritance hierarchy, we can provide specific behaviors for things lower down on the chain to differentiate these things. So all dogs are animals, but not all animals are dogs, for instance. And that's usually described as the is-a relationship. So properties are described as the has-a relationship. A dog has a tail, whereas a dog is an animal. It doesn't have an animal. It is an animal. Right. So let's implement that in Java. So I will start by implementing an animal class. I haven't already implemented an animal class, right? I used throttle as the original class example. So we'll create an animal class. And for time and speed, I'm going to implement a very simple animal class. We'll say that this animal can, it has an age. It has a name. That shouldn't be an int, that should be a string. Let's give it a constructor. Public. And all this constructor will do is save an age and a name So this dot age equals age. This dot name equals name. I should create mutators and accessors for those properties. So there's getAge. There's setAge. There's getName. And there's setName. Most of setName. There we go. There's setName. Okay, so that's the attributes of animal taken care of. Let's write some operations for animal. What I mentioned, speak, eat, and move. Let's make something a little bit more interesting. So, slightly obfuscated statement there. Basically what I'm doing is getting the age, then incrementing the age, and then getting it again, and placing it in different pieces in the string. Because if we're celebrating a birthday, the assumption is that this animal is now 1 year older, so its age should be incremented. I could do this in multiple statements by, for instance, old age equals age plus plus, and new age is age. And then my print statement. With old age and new age substituted in the right places. I'm also going to, we've already talked about overloading, writing two methods with the same name that take different sets of arguments. So let's create an eat method that takes an object. And we know that because of the toString method, adding an object to a string results in calling that object's toString method, concatenating the two together so it will print out a string and print out a string representation of the object. I think that should be good for now. Let's create a main method so we can actually use this animal class. There we go, that's felt better. And let's do things with some of these animals. Let's call speak. I don't think I gave move an argument, did I? Nope. Okay, create two animals, tell Bob to speak, move, and eat. At which point we know that Bob will complain that he needs objects to feed on. Then we feed Bob J, which results in cannibalism. And then we pass some other objects that we've already dealt with and already seen. And the reason for doing that is I'm using the eat method to print out these objects and show what they are. And one thing that we'll see is that because all of these things are objects, even though they're different objects, system is actually it's a class, so that'll be a little bit interesting when it prints it out. New scanner system.in will be a scanner, and system.in is a input reader, I believe. So they're all different types of objects, but they are all still objects. They all inherit from objects. So we can pass them into this method that takes something of type object because of this inheritance property. So we can compile and save along the way, and but I didn't spell it wrong. Let's do that. System is a type, so it can't be an argument by itself. But because everything in Java is an object, a representation of the class is also itself an object. And there are some useful properties of that, which I'll talk about in a minute, very briefly. Okay, so Bob is an animal. Bob knows he can move, but he doesn't know specifically how. He wants us to feed him objects. First object we feed him is an animal with some reference. The object I am eating is class java.lang.system. That is the system class, and every class has a public static variable called class, which represents its class definition. So if you wanted to print out the basically the type of an object, that's how you would accomplish that. Next, we're eating a scanner, and scanner's toString spits out a lot of good information, which some of it's useful. Delimiters, we've seen delimiters before. Source closed is another interesting one. Scanners can be used not only on system input, keyboard input, but also on files. And it makes sense with files that a file can be closed. Actually, it makes sense that keyboard input can be closed as well. When a scanner, if you create a scanner on system.in, and then that scanner gets destroyed, goes out of scope, as some of your simple calculator programs did. If you declared the scanner and initialized the scanner inside the loop, as soon as that first iteration of the loop executed, the scanner disappeared, and when a scanner gets destroyed, the underlying file that it is operating gets closed. So the next time around through the loop, it said, this file doesn't work. I can't get anything from it. And apparently system.in in this case is edu.rice.cs.drjava.model.repl.newjvm.interpreterjvm $1, which is some internal thing to basically the JVM. If we'd run this from the command line, I think that last thing should give us something a little bit more sane. There we go. Java.io.buffered input stream. Everything else is pretty much the same. Alright, so I mentioned that this system not class thing is kind of useful sometimes. Turns out that Java being fully object-oriented and everything is an object, classes themselves, even our objects, supports a concept called reflection, which means that as you're running your program, you can inspect the classes themselves and determine what methods they have at runtime. And this is one way, more advanced way, that you can actually determine if a specific class you're using supports a specific functionality, which in theory is how I should be testing your programs. As of right now, I'm not. I simply try to compile against your programs, and if compilation fails, I assume that your class does not implement the methods I'm trying to call and spit out some error message. So if you see the message, this class did not implement the proper functionality, that's what happened. Question?
I have a question about this.
Mm-hmm.
On your animal class,
Yes.
for the method eat,
Yes. Which one?
that use object A is the
Oh.
argument.
So,
Because you never declared object.
so object is something that's provided by Java. Object is the root of the inheritance hierarchy. Everything in Java is an object. Even animal, even though I don't specify animal is an object, by default animal is an object.
So Java takes any object that you declare and use the object.
It's basically a wild card. You can pass anything here. Now in Java, you can pass anything here. You can actually pass primitive types in because of the integer class, the double class, the way they work.
So integer type is an object.
Yes. So I guess we should celebrate Bob's birthday as well. I can also say bob.eat 4. And let's get rid of that. The object I am eating is 4.
So you just type in the object as it takes eat is the method, and then whatever you
Basically,
fill in the parameter takes place object.
right. Declaring it as taking something of type object means that it can take anything. You can pass anything into that method and it will accept it.
Why did you write object A just to give object B?
Because that's method argument syntax. I have to give it some name in order to use it inside the method. Alright, so that's kind of inheritance behind the scenes that Java provides for us. Now let's actually use inheritance to our advantage. And I am going to create, are we mostly dog people or cat people in here?
Dog.
Dogs? The vocal ones are dogs, okay. So, I've mentioned before, this is the simplest possible class declaration that I can make. And at this point, dog has pretty much absolutely nothing, except by default it inherits from object. So it has everything that object provides. I can't do anything about that. So this dog class automatically has a toString method. It automatically gets some reference in memory. That's just what happens. That's how Java works. But without doing a whole lot of extra work, I can give dog all the same functionality that animal has. Not by doing that. By saying class dog extends animal. And by doing that, I have access to everything that animal has, with one very, very important exception. Constructors are not included in that. So if I were to, for instance, let's save this first. This file already exists. I created a doc already? Let's not do dogs. Let's do badgers. I picked an animal that I was pretty sure I'd never used previously. Right. So if we go back here and change this to badger and badger, it will fail to compile. Because it's a very odd error that it gives. But it basically says that it has no idea how to create a badger. Because of this. We're calling some constructor that is not the default constructor. Now if we do that, it still complains because it's really an issue with how constructors do and don't get inherited. Basically, it's complaining that there is no noargs constructor on animal, which is in fact the case. We specifically implemented a constructor, and that means that the noargs constructor goes away. Now, when objects are instantiated, Java kind of goes up the inheritance hierarchy and instantiates objects of each of those types. So, a badger being an animal, Java needs to somehow create something that is an animal. And it has determined that it can't do that. So one way to solve that problem is to do something like this. Now there's a noargs constructor that does absolutely nothing, which is essentially what Java automatically provides if you don't specify another constructor. And then we should be able to do something like that. And that works. The thing is, we don't really want to leave things unspecified. We want to give this badger an age and a name. But if we try to compile that, it basically says badger doesn't have a constructor that does that. So constructors are not inherited. Just because I have a constructor on animal that takes an int and a string does not mean that Badger automatically has a constructor that does the same thing. So let's go back to Badger and fix that. Public Badger age string name. And for now, I'm going to make it not do anything. And everything compiles fine. So all we need to do in order to make line 5 work is implement a constructor on Badger. However, what we really want that constructor to do is specify the age and the name, or set the age and the name. So something like this. However, oh, right, quick note. This constructor automatically calls the NoArgs constructor of the parent class. So maybe. I'm not sure if that's accurate. Let's find out. Yes, it does. So for now, that needs to be there. So let's bring these statements back, and this will not compile. It says age has private access in animal. So remember what it means to have something be private. It means that nothing outside the class can access it, and that means nothing. It doesn't matter who inherits it. It doesn't matter what package it's in. Nothing can see that variable. So we have two options. We have a constructor on animal called a parent constructor that does essentially what we want it to do. So we can use that, or we can make these variables accessible to Badger since it inherits from animal, but not accessible from anything else. And I will show both ways of doing that. The first way that requires the least amount of change is change these to protected. The book does talk about protected, right? Well, if the book doesn't talk about protected, we're going to talk about protected right now. Protected is somewhere in between public and private. So public is everything in the world can see this. Private is nothing in the world except for this class can see. Protected extends that privacy to include child classes, classes that inherit from the class where things are declared protected. So now Badger can access age and name, but OOP demo cannot. And if we click compile, Badger compiles, everything works fine. And now we can actually run this for the first time in a while. And this Badger does everything that animal can do. Exactly the way that animal does it. Even though we haven't implemented a speak, move, eat, celebrate birthday, eat object method on Badger, it's already on animal, so because Badger extends animal, everything is already available to Badger. Questions so far? So the other way to accomplish setting the age in the name is, so let's change these back to private. So again, doesn't compile, is to call a constructor on the parent class. We've already seen how we can call another constructor on the same class by using this, the this keyword with parentheses and optional arguments. We have a similar keyword to call constructors of parent classes, and that is super. So by simply calling that, we will actually invoke the constructor on the parent class. And test number 1 is that it compiles. Few caveats with use of super. Most books and most instructions will say that a call to super must be the first line in your constructor. Some versions of Java and some Java compilers do not enforce that, but that doesn't mean that it's okay to not have it be the first instruction in your constructor. It is always a good idea to first do that, because a lot of times inside constructors you assume that this object has been set up as an instance of the parent object, and that doesn't happen unless you have told the constructor already. I have encountered situations where I would like to perform some logic before I pick what constructor I'm going to call, but those are few and far between and often solved by other, better ways. Helper methods, for instance. So I already did that. It compiles, and we can go back to OOP demo and run, and everything, it prints out exactly the same thing as it did on the previous run. Questions on that? So just because we have implementations of these methods doesn't mean that we're stuck with those implementations of these methods. We don't want badgers to go around saying, I'm an animal, I'm an animal. We'd rather they say, I'm a badger. So let's change that. Public void speak. The way to do that is just to implement a method with the exact same method signature. Now if we compile this and run this class, it should say I'm a badger. I'm a badger. We didn't implement a specific move method, and we didn't create new implementations of the other methods, but we could do those just as easily. This is called method overriding, which is different but sounds very similar to method overloading. Overriding is when we create a new implementation of a method in a subclass or child class. Overloading is when we have multiple methods with the same name but different sets of arguments. And similar to how we call constructors from the parent classes, we can actually call the parent's implementation of a method that we're overriding. And that's, again, using the super keyword, a very similar fashion to using the this keyword, except it's the super keyword, then dot, and then the method name. I think we can actually call any method we want to, but really the only useful way to use this is to call the method with the same name. And the reason you use the super keyword is to differentiate between the implementation on the current class and the implementation on the parent class. If we just call it speed, we'd have basically an infinite loop, something called infinite recursion. We call a method, then that method would call the same method and call the same method again, and continue calling it until Java explodes, basically. So I'm going to change this to, say, in particular, I'm a badger. And can anyone tell me what the result of calling speak will print out? Since it's calling the...
If I'm an animal, in particular, I'm a badger.
Correct. I'm an animal, in particular, I'm a badger. Let's see. I think the only thing left to talk about is the final keyword. So we've used the final keyword in the past with named constants. The meaning of final basically means this cannot change. Whatever this name refers to cannot change. So with named constants, it's the value of this variable can never change. We can also use it to apply to methods, but until now, there's been no possibility that a method could be something other than what we define it to be. In the case of inheritance, the final keyword on a method means that this method cannot be overridden. This is the definition of this method for this class and anything that extends this class. So let's so mutators and accessors, because they can't actually get to the base data, that might be a good opportunity to use final. In general, I think it's kind of unnecessary, but let's I think I have the order backwards in there. But we make celebrate birthday final, meaning this can't be overridden in a subclass. Because there's, in our world anyway, there's really no reason for anyone to celebrate a birthday any differently. Celebrating a birthday means that the age is going to increase, and we'll print out a little message, always. So if I wanted to, if I tried to override celebrate birthday in the Badger class and say something like Badgers don't have birthdays. Apparently they also don't get older either, and they don't know how to use apostrophes. We try to compile this and it will fail horribly. Celebrate birthday in Badger cannot override celebrate birthday in Animal. Overridden method is final. It's really a long-winded way of saying you can't override that method, period. No ifs, ands, or buts. That method has one implementation, and that's the only implementation it will ever have. So basically we can't do that. Let's comment that out. And since we really didn't change much else, that makes it compile, and we can run it, and badgers still celebrate birthdays. And this is one level of inheritance. We can go even further. We can create cartoon badgers and real-world badgers, both inheriting from badger. We can go beyond cartoon badgers and say flash badger and there is a cartoon that actually has a badger as a character, isn't there? I'm pretty sure there is. And in the Java framework, there are a lot of things that have very deep inheritance hierarchies. Everything starts out at object, and then so system.in is a good example. The inheritance hierarchies in Java are pretty easily determined based solely on the name. So everything is an object. Let's take system.in for instance. When we printed it out at the console, it said it is a buffered input stream. So there is object, then there is something called stream, which basically is a way of interacting with data. Then there is something that is an input stream, which specifically deals with data coming into the program. And then there's something that extends that called buffered input stream, which it buffers the input stream. It provides some way of mediating between the actual data that's coming in and your program that's trying to access it. And there are other things in the Java framework that have names like that, that basically, as you go down the inheritance hierarchy, you get longer and longer names. Questions on the first half of inheritance, or the first half of the second half of object-oriented programming. I'm pretty sure I talked about everything in the first 3 sections of Chapter 8, with the exception of UML. Let me make sure I covered everything else, and I'll say a couple comments on UML. I'm going to hold off on talking about the equals method until Wednesday. Maybe. I don't know if I'll talk about the equals method. It's in the chapter. It's worth reading about. I think that's it. Okay, so UML. It is often convenient to describe programming constructs without writing code. When you're dealing with design, for instance, you don't want to deal with the implementation. You don't want to have to make the compiler happy. You just want to describe how classes are going to look, the interfaces that they're going to have, what methods they'll have, what attributes they'll have, how they'll interact with other classes, and it really helps if there's some convention that everybody's following when everybody's talking about these things. One of these conventions is called UML, Unified Modeling Language. The important part is that everybody understands what everybody else is talking about. UML has gained popularity, I'd say, over the past decade or so. And for the most part, it's pretty straightforward. Instance methods get described with a minus in front of them. Static methods get described with a plus in front of them. And a class is represented as a box with a title, a smaller box with attributes, and then a box below it with all the methods on it. So it's really nothing special. It's just something that's been standardized over the course of the past decade or so. It's worth being familiar with. I am sure that some companies use it. I am sure that there are some companies that do not use it. It's one of those things that you can get away with whatever convention you want to use. And it's like any communication. If the other person understands what you're talking about, that's the goal. So it's worth being familiar with. It's worth knowing that there are things that standardize this type of communication, but you're not going to need it in this class. That said, you may find it helpful in designing programming assignments in this class. I don't describe the classes required for the programming assignments in terms of UML, but I don't think it should be that difficult to take what I've written and turn it into UML. I've tried to write in more of a narrative style. Actually, I've tried to write the way I would talk to describe a class. And with UML, you don't get any of the ideas of what this method should do. It's just, there should be a method, call it this. So those are my comments on UML. Any questions on sections 8.1 through 8.3? Cool. On Wednesday, we'll talk about section 8.4, which I'll probably use much of the same example and just build on it. Section 8.4 is kind of fun. After we talk about section 8.4, we're pretty much mostly done with the semester. So next class is interfaces and abstract classes. That marks the last piece of Java that fills out your knowledge of how to use Java. So after that point, you know syntactically pretty much everything there is to know about Java. There's one topic that you can get away without knowing that we'll talk about a week from today called exceptions. Java really likes exceptions, so it's a good thing to know, but it's not something that I usually try to avoid using exceptions when I write Java. And then, let's see, a week from Wednesday, and then 2 weeks from today, we're talking about file input and output. So we'll use scanners on files, not just standard input, and recursion, which I actually mentioned earlier today. Calling the same method over and over again, but in order to do it properly, there are some conditions that you have to follow. And that's pretty much the entire book. I think the only thing that we're not talking about, let's see, the last chapter? Yeah. We're not talking about chapter 12, though if you would like to, you're welcome to read that. That will give you a good foundation for 1450, because 1450 takes chapter 12 and makes an entire semester out of it. Talking about specific data structures. Generics are another piece of the syntax of Java that we're not talking about, that is useful if you know it, but it's not necessary to use Java. think that's pretty much it. I have sections 10.4 and 10.5 marked as optional, and I'm not sure why. What are sections 10.4 and 10.5? Oh, binary file I/O. We probably won't talk about that. We'll deal with plain text files, things that you can read with Notepad or something like that. We won't worry about binary files. You may encounter binary files later on, but a lot of the techniques for dealing with binary files are very similar to those for dealing with text files. Just you have to keep in mind that the bytes that you are getting out of the file are not characters. Don't try to treat them as characters because bad things will happen. So, really, at this point, you have all the knowledge of Java necessary to start solving problems, solving real-world problems, not contrived problems, using Java. So, congratulations! This is a very big, an important point in this semester. I guess we'll take a 10-minute break, and then when we come back, I'll figure out some exercises that can give you practice for dealing with inheritance hierarchies and that sort of thing. We'll also do FCQs on Wednesday. I'll make sure I have pencils for that. Faculty course questionnaires. You get to grade the professor. So don't miss out. You get this bubble sheet, and you get to fill in little bubbles. It's really cool. I don't see them until well after the course is over. I do look at them. I do take them seriously. Some of the questions they ask, I think, are maybe not necessarily the right questions to ask, and some of the scales are a little odd. But in general, I found them useful. When people tend not to just write random answers, and they actually give good feedback. There's also a spot somewhere on the forum for it's just a big blank area, and some people have specific questions they want their students to answer. I don't, but if you write something there, I will look at it. I like feedback, but that's not the only type of feedback you can give. You're welcome to come up to me and say, "Hey, I really didn't like your course. I thought you could have taught it a much better way." I won't get offended. Your grade won't be affected by it. That would be unfair, very unfair. But I do like hearing feedback. I do take that into account, modify the course. This semester has definitely been much less rocky than last semester was, even though I was using a totally different book, just because I had experience teaching students at this level with this material before. So you got round 2. This is version 2.0 of me teaching this course. I made all my mistakes last semester, so hopefully it showed. So yeah, we'll do FCQs on Wednesday. Tell all your friends who didn't show up today. They don't want to miss out. All right, break time.